What do you think is the most commonly accepted theory that has the highest chance of being overturned in the near-ish future? Wow, I mean, in physics alone, the point is that we really have almost no understanding. Welcome to a special 500 episode edition of the Into the Impossible podcast featuring my favorite guest, me, Professor Brian Keating at UC San Diego. Delighted you could be here. I'm even more delighted that this project I started during COVID-19 5 years ago has amassed 500 episodes. That makes it about 100 per year, which is quite incredible. Doesn't seem like that would even be possible, but somehow I did it. I think early on in the pandemic, I had nothing else to do except listen to my kids try to drive each other crazy and teach over Zoom. So I think I front-loaded a lot of episodes, but I'm still doing 1 or 2 a week, which is quite incredible. I never thought this would amount to anything like this, but I'm so delighted that you're here. And I'd be even more delighted, and you might be delighted, because you might win one of these chunks of our history, not of the podcast, but of the universe, of our solar system. This is a real meteorite, and you can win one if you go to briankeating.com/YT. And if you have a .edu email address and you live in the United States, you're guaranteed to win one of these beauties. briankeating.com/edu. So make sure you check those out right away. Let's get on to the questions. Okay, starts off with an awesome name, Rockstar Music Company. One thing you want to be asked about that nobody has ever touched upon yet, for whatever reason. Well, that's a pretty awesome question. That's basically asking me to ask myself anything. I would say the most kind of pertinent question that I have not yet been asked is, what drives me to do what I do? I mean, I don't have to do the podcast. I don't even have to teach anymore. I could sort of quit and just do the podcast, or I could do the podcast or teach and not do the podcast. But why do I do both of them? I think it's something that I assumed was normal in scientists, that they would be thrilled to discuss the greatest subjects of the human mind and the curiosity of the human spirit. And I actually found out it's not the case. Scientists are, in general, like anybody else. They have their quotidian demands in their lives, and they really can't get back to the essence of what got them to be scientists maybe in the first place, which was this childlike curiosity. And part of that is because I think scientists aren't like children. I always say children are wonderful. They're curious, they're imaginative, they're inventive, they're creative, they're whimsical, they are touchy, they are selfish, they don't play well with others, they are jealous, they are petty, they are unscrupulous. And so, yeah, scientists are like children. And sometimes it gets to a scientist and makes them less of the scientists that they originally wanted to be or thought that they might be. And because of that, I think we lose out on some of the passion that we could have had or should have had maintained since we were kids. I never thought I could be a scientist. As I wrote in my first book, Losing the Nobel Prize, I thought being an astronomer as a professional was like being an ice cream taster, a professional roller coaster, amusement park patron who would pay me to do what I love. And don't tell Gavin Newsom. He might take you up on that and dock my salary. But screw you, Gavin. I've got tenure and I've got the side hustle that people have dreamed about. For me, I've not lost it. I thought it was normal not to lose it. And I've loved teaching. I've loved even dealing with faculty committee. Okay, I don't love faculty meetings and so on. I skip most of them, unfortunately, just due to demands of family, friends, and other tasks as the leader of a huge experiment. Right now, it's quite incredible time for me personally, professionally, and even as this, my side hustle. And I am trying to step things up. You may notice this beautiful new studio lighting setup I made in my office and another one on campus in a different location. My wardrobe, I'm wearing red, white, and blue today, is 4th of July. I'm recording this before I take the kids down to the beach in San Diego. So why do I do what I do? And I think it's because I can, because I love it. I love the microphone and I love having the mouthpiece and being able to talk to pretty much anybody. And 20 minutes after this ends, I'll be talking to a Nobel laureate who asked me to come on my show because he has a book. So that's number 22. And he is not alone. Many, many other Nobel laureates have asked to come on the show, and many more will. And my newest book, coming out on my birthday, September 9th, 2025, is called Focus Like a Nobel Prize Winner. And that's the 9 subsequent interviews, the second block of 9 interviews I've done with Nobel laureates since starting the podcast 500 episodes ago. And that's just been an incredible treat. So I can do it. The rich get richer in the society, and I get richer guests, better content, and it just keeps flowing and acting like a self-reinforcing positive feedback loop. So I'm going to keep riding this wheel as long as I can. I feel young, energized, and ready to keep going. Okay, goat-worthy. So maybe this is greatest of all time. Ask Dr. Keating, in your view, what would it take for a 4-dimensional, covariant, geometrically complete, unified field theory to be taken seriously by the community again without appealing to extra dimensions? Well, goat-worthy, I think, to be taken seriously, like any other scientific hypothesis, it needs to have some testable conclusions in the 21st century, not in the 25th century, and not even as people like Eric Weinstein have said, and we'll get to Eric. There are a lot of questions about Eric, as I suspected there might be. His first appearance in 2 years on the podcast, in person, that is, led to a lot of questions and a lot of commentary, some snarky, some snide, some genuinely curious. So as I say to Eric, we need to have theoretical predictions that are borne out by something that is in principle testable, and better yet, testable now. And in fact, people ask me, as we'll preemptively see later on, I suppose, but preempting that, there are testable predictions that Eric makes that we can actually rule out or confirm right now. And that's sort of the challenge I have dealing with all these theories, that typically they'll produce results that are similar to the existing theory that doesn't involve a claim to be a theory of everything. But in this case, it's a unified field theory. I assume you're asking about the theory of everything, where all 4 forces are unified. But even so, I always joke we put the toe, theory of everything, before the gut. I mean, after all, my friend Kurt has a show called A Theory of Everything, Not Grand Unified Theory. We don't even have the 3 higher energy forces: strong, weak, nuclear forces, and electromagnetism unified. We have electron-weak unified, but we don't have weak with strong and electricity and magnetism, let alone with gravity. So I think we need that before we can even think about really pursuing a theory of everything. Now, it may not be geometric. I mean, there may be other ways to approach a theory of everything, or even a grand unified theory, rather than geometric. Certainly, we'll have to have some lower energy completeness that is geometric, because we know that the 2 of the 3 forces, well, I could say electricity and magnetism are one force, but the electroweak force is unified. So that is manifestly done through geometric unification, SU3 cross U2 cross U1, and that maintains Maxwell as well, but it doesn't fully take into account gravity or the strong force. So we have a separate theory of the strong force, the SU3 part, but we don't have a true unification where they could be said to have a similar coupling constant or similar static behavior at high energies at early times. Next question comes from Rahman 5935. Is there any limit for understanding? And then a heart emoji. Thank you very much. If the human mind is a computer, if there is a universal computing capability of the human mind, therefore we would have to say that there's no limit to what we can understand. There may be limits to what we can perceive and sense. In other words, we could understand, for example, string theory, but we can't perceive it. We can't detect any manifestation of it that is present and instantiates it in our 3 plus 1 dimensional space plus time dimensional reality. So we can contemplate things, and we can even work out very intricate mathematics, but to say that we understand something means that we have approached the reality of it. Now, in an upcoming episode with David Deutsch, we talk about his optimism, even though he's a very contrarian mind. Talked to him for 2 hours. He's very optimistic in some sense that we're closer to the beginning of infinity, the closer to the beginning of understanding, if you will, than to the end. But he bases this on constructors and says human brain is a constructor. I had my brain out that my kid made for me, and he loved the brain. And yet we don't really have any sense that we can perceive when we've gotten to that. I always joke, echoing Woody Allen's quip that eternity is pretty long, especially towards the end. Infinity is pretty big, especially towards the end. And so getting to that level of the limits of understanding, meaning a finite bounding on understanding, would contradict what Deutsch is claiming. I don't know if there's a limit If there is, we're nowhere near it. And if there isn't, how do we know? So it's a fascinating question. Memes of Destruction. I should point out, Memes of Destruction is a good friend. He is also a channel member, and I would like you to become a channel member too if you're watching this. I do it for a couple of reasons. The sweet, sweet 99 cents per month that each of the 80 people in that domain kind of contribute to my monthly salary that allows me to pay an editor the exact same amount as they pay me to edit this video, to put it out. So it's kind of self-defeating. But nevertheless, there are higher tiers, $4.99, I think, a $9.99, and a $19.99. Now, the $19.99 a month is not there to make boatloads of money again. It's there to incorporate those people who think they have serious ideas that would like a serious physicist, i.e. me. I've got a PhD. I am a member of multiple honor societies, American Physical Society, which is the premier physicist society in the world, as well as multiple recipients of multiple medals. I'm a chancellor's chair professor, distinguished professor here at UC San Diego. So my bona fides, I think, are pretty strong. So if you want my time, my students pay me for my time, okay? They pay tuition. That eventually goes to my salary. So if I get these emails, as I often do, not from memes, but from other people, I get emails. Professor Keating, I've got this incredible idea to transform our understanding of gravity, of unification, of cosmology, of aliens, of biology, of ontology, of epistemology, of broccoli, whatever it is. I'm very fascinated in that. And so I write them all back. You can either have a private hour with me for the same rate that I get paid when I consult with Qualcomm or some other organization here, $1,000 an hour, all of which goes to charity here at UCSD and the Triton Food Pantry for the food insecure students that I have to teach, or that have to suffer food insecurity while they're teaching me, who obviously doesn't suffer from much food insecurity. I have other insecurities. But that's an excessive rate, I am sure, but I have to value my time, because if I'm spending it looking at your theory, which you have to admit could be completely wrong, since I do get 7 of those emails a week, it can't all be right, but I'm willing to entertain it. But so far, no one's taken me up on the $1,000 an hour. So instead of that, I take hopefully 50 of you together in the highest tier at the $19.99 a month level on YouTube. You can just click on the membership, select Cosmic Office Hours, and you'll get an hour with me every month as well. And we talk about all sorts of stuff. Everybody gets a voice. Everybody gets to chime in and have their theories vetted in a non-judgmental, exceptionally qualified group of individuals, and some people that are playing a physicist on TV. But Memes does that. He does show up every month on these incredible 1-hour gatherings where we get people there. And if you're I'm also on Patreon, you can do the same thing, same price over there. The next one's coming up in a few weeks. We just had the first one, but I want to answer Memes' question. If early galactic formation rate ends up being faster than previously thought, what experimental techniques do we have to isolate this additional early light? So the experimental techniques that we would have would be deeper infrared sensing. So referring to the James Webb Space Telescope, observations of mature, highly ordered, structured, spinning galaxies at very high redshifts. Well, that redshift means that the light is going to be far redder than, say, the Hubble Space Telescope's capabilities were, and potentially could be even higher than the Webb telescope's longest wavelength imaging capability is. They have spectroscopy over a wide range of wavelengths, very long infrared, near and far infrared, but that does not cover perhaps the entirety of the redshift range in which galaxies could form, and we just don't know. The problem I have is I've told other people, and people like Eric Lerner and the Thornbirds or Thunderbolts, I don't know, these guys. I'm having a reaction video on my other channel, which you can subscribe to, Professor Keating Experiments. We'll be discussing that more and more. There's a recent claim that the CMB itself comes from these early galaxies. It's total nonsense, blown out of proportion for engagement farming to the tune of 2 million views on Twitter alone. But that was a really kind of excessive interpretation of what the authors claim was at most a 1% contribution to the CMB, which I don't even believe is correct, because the spectral distortions and the CMB polarization measurements that I do have completely invalidated additional energy injection sources other than black body thermal radiation left over from the formation of the first elements on the periodic table and formed during the epoch of recombination. So we'll talk about that. I'm going to definitely talk about that at the next office hours. So make sure you join up. Be like Memes. Okay. MSOD7JE. In your opinion, does my opinion count? How do opinions count? Is math the same for an opinion? Does your opinion of my opinion opine significance in relative to other? Do I have an option to be opinionated? I thought he should have said, do I have an opinion to be opinionated? Why do you trust or believe in your opinion of opinion? What is the matter of opinion? Do opinions hold power over matter or matter or mind? I'll take this seriously, even if it's not. Certainly your opinion counts in the sense that everybody's entitled to their own opinion, but not everyone's entitled to their own data. And so data is the hard truth and so forth. And you're not entitled to your own facts. You can have your own opinion. Fact data can be interpreted as facts. Is math the same for opinion? In terms to the limit that math refers to the degree of ordinality of opinions. In other words, it was my first opinion. I want a second opinion from my doctor. Yes, that's a math application to opinions. Certainly that's true. Does your opinion, meaning Brian's, of his opinion, opine significance in relation to other opinions? That's incorrect grammatically. Opine significance, it means maybe he means obtain significance in relation to other opinions. Well, to the extent that opinions are personal, there's a wonderful Latin expression which I get to break out on occasion, de gustatum non est disputandum, meaning that taste is not debatable. You can't tell me that fish tastes good. I'm sorry. People always want to convince me, go out for sushi and go out to, I hate it. Because I say to them, what's the highest compliment that you can ever pay to a fish dish? The answer, it doesn't taste like fish. So what I do is I just skip the middleman. I just go right to the not eating fish. And that, you know what, doesn't taste like fish. So next question comes from 10-minute retreat 807. Do you think the fact that there are 3 generations of leptons can somehow be explained in terms of the dimensionality of spacetime? That's an awesome question. In other words, maybe the lightest generation do some field acting in only one dimension, the middle generation is a field acting in 2 dimensions, and so on. This is an excellent question. So I just had this conversation with an esteemed physicist at NYU, Greg Gabadadze. He sometimes listens. I asked him the exact same question, not having read this. This question came in 4 days ago. I talked to Greg 7 days ago. What he told me is that there's no guarantee you might not find a 4th generation of leptons. And in other words, these come from fermions. So the 3 generations of leptons are the electron, the lightest of the elementary particles that participate in electromagnetism in terms of fermions, although neutrinos also have mass, but we don't know their mass, and they are fermions as well. They're not counted in terms of lepton number, but we can talk about that. Or they are counted in terms of lepton number, but they're also fermions. I don't want to get into that. They're related to the 3 generations of electrons. Sorry, the 3 generations or 3 flavors of neutrinos are related to the 3 generations of fermions, therefore of leptons. So these all have spin 1/2. And I also asked him, is there a reason that we don't see spin 3/2 elementary particles? And I had a wonderful conversation with Nima Akani Hamed. He's agreed to come on the podcast. I actually have his number now. I'm going to text him soon after this to set that up because he gave such a phenomenal talk. But I thought there might be other processes going on that make the masses what they are. We don't know. So there could be another 4th generation of fermions that could then be in conflict. So there's nothing permanent about this. And exactly your question would have resulted in a non-confirmation of your hypothesis, which is also my hypothesis, back in the 80s when we didn't know of the tau particle and we didn't know of the tau quarks associated with that 3rd generation of fermions. So if we had said that dimensionality of spacetime has to correlate, maybe we could have predicted in 3rd dimension, but what happens when a 4th dimension shows up? So there are no laws that restrict the number of generations of leptons, and so therefore I don't think it can be related to the dimensionality of spacetime. Screwdriver tuning. What is the future of GU, geometric unity, Eric Weinstein's theory? And is him labeling himself as an entertainer, ultimately theory's cinder block in the river? Or will it be the new potential for future ideas? Look, Eric's theory is incredibly provocative. I think it is provisional. I think a lot of the hostility that comes to Eric is because he does label it entertainment. He puts it on the paper. I'll have more to say about Eric later on when it talks about having on the alternative people to question him and comment on him, and including Sean Carroll, who I think was a relatively disgraceful performance, kind of attempting at humiliation of Eric. Eric didn't do himself so many favors in that conversation with Piers Morgan. Very much down on Piers Morgan myself for many reasons, but Eric and I fight all the time, and it's very funny for people that say, oh, I'm just his lackey and all I could do is prop him up. But there are testable predictions that he attempts to make. And he is very excited to want to test those. But the problem is when he tries to test them, people say, well, where's the paper? Where can I reference it? And he says, oh, here it is. And it's on April Fool's Day 2021 or whatever. He and I made a video on that day as well when he released it. But yes, he did, and I encouraged him. And look, I take some of the credit for him forcing him, and along with Stefan Alexander, my good friend, to get him to actually bring this to publication. It is published. It's not refereed. It'll never be refereed in its current form. The reason he puts it on as an entertainer is so that he can assert copyright. So when people do try to take his credit for his ideas, as he claims, look, I wasn't there. He claims that the Seiberg-Witten equations were his idea. He didn't label those as copyrighted. He didn't publish them either, so I can't verify that. There are people that can testify to him doing that, according to Eric, and there are books written about how this whole episode played out. So I think the future of it has to be very challenging, and there's no doubt about it, because very few theorists will take it seriously, although I did host him here for a very entertaining day of lecturing and podcasting, and many of the top relativists in the world, including the chief final collaborator of Steven Weinberg, is very much enthralled and interested in it, not just with his personality. Dan Green, as you know, has had debates with him, another colleague here. I don't just put him off with patsies that just are sycophantically licking his boots. So I don't know. Eric's got a lot of problems with peer review that I don't share. Oftentimes I wish he could be more conventional, more orthodox, but maybe that would squelch his ideas, and maybe indeed he has been abused by the system that he's railing against. Can you make Jim Romanowski 66? Can you make a video with Sabina Hassenfelder singing together? Yes, that's on my bucket list. I do have a podcast with her coming up. Hit the subscription notification bell to make sure you get access to that. You'll see a very brief episode, perhaps, of her singing and me playing the Spotify instrument, the only instrument I can actually play. Okay, I'm going to take a break right now. I'll record a podcast with the Nobel Prize winner, bring that to you live, or not live, recorded soon, long after this comes out, actually. But stay tuned. I'll be back in a little bit. Many of you are watching this on a television, and I know that if you love the cosmos as much as I do, you'll want to subscribe now. It's a little more tricky on TV, but it's well worth your time. Click down below, and don't forget to leave a thumbs up. More minds, more mysteries, more multiverse awaits you. And we're back. That was a great interview with Dr. Lou Ignarro, author of Dr. No, inventor of Viagra, teach you how to keep your member pointing straight. And speaking of members, don't forget to join my membership on the Into the Impossible podcast on the YouTube channel or on Patreon. You can support me and offset some of the expenses that I incur doing this wonderful show. Just show your love. And if you're one of the folks in the uppermost tier, the $19.99 tier, you're guaranteed to spend an hour a month with me on my Cosmic Office Hours. So that's the YouTube membership link down below. If you're watching or if you're listening at my Patreon, Dr. Brian Keating on Patreon, you can join there and you'll get all access to yours truly, or you'll just show your love and get your name featured and get your chance to ask questions of all my guests. Don't forget, you can always ask me questions if you're a subscriber to the channel. So don't forget to become a member of the channel and maybe even a paying member. Again, membership start at 99 cents a month. And it's really just to signal to the algorithm in my heart that you guys care about what I'm doing. I really hope you do. Okay, Quantum Cath asks, as an experimental physicist, do you prefer to design an experiment with the hope of producing the desired outcome? Or would you rather produce an experiment where you get to see what the outcome might be? Is it you who analyzes the results? Okay, good questions. I love designing experiments. I have since I was a wee lad, age 5, designing homemade pesticides and explosives, much like my hero, Galileo Galilei, who took a telescope that he made also and turned it towards the sky and did the first scientific research in history, demonstrating that the universe has objects that orbit around other objects besides the Earth, in that case, looking at Jupiter, and that changed the universe. But as I say, you can't have your own Higgs boson detection kit, or even if you do, a Large Hadron Collider at your own disposal. You won't feel what it was like to discover it, quote unquote, because it unfolded over years and years and years. But you can feel exactly what Galileo felt the moment he saw the craters of the moon, or the rings around Saturn, or the moons around Jupiter. And you too can become a scientist just like him, or for the child that you love in your life. So I have the telescope buyer's kit. I don't get any money from it, really. I go to briankeating.com/telescope. and you'll get a buyer's guide and a viewing guide. And also when you join my mailing list, that same link will take you to my mailing list. You'll get information on how to see meteors and meteor showers, and maybe even collect meteors, and maybe even win one of these meteors or find one yourself. Who knows? So I love designing experiments. Yes, you're always trying to discover. I mean, you don't build an experiment purely serendipitously. I do believe that serendipitous outcomes are the most beautiful, pure outcomes that there are in science, because something you don't plan on, serendipity by definition. So I think it's quite delightful when you discover something unexpected. Rather than saying eureka, as Isaac Asimov once said, you shouldn't say eureka, I have found it, because that's kind of portrays and belies the confirmation bias that's inherent in what you're doing. So I love to see what the outcome is of the experiments that I designed. I've designed at least 2 of the most major experiments in my field, BICEP and the Simons Observatory, are kind of my brain children, both of them, and I participated in building them, designing them, supervising the brilliant people that do most of the hard work and deploying it. Gone to Chile and the Antarctica, South Pole many times. And so it's just a thrill to be able to do that. It's quite frankly well beyond my wildest dreams to have built these experiments in these wild places, gone to the South Pole twice and Chile more times than I can count, launch rockets into space from White Sands Missile Range, take pictures of the infrared background. It's incredible. So, and I love looking at the results, but it's a tedious process. Experimental physics takes years. And I think that's part of the reason I love this podcast so much, is because I get instant gratification. This guy, again, Dr. Lou, called me up, texted me, can I come on your podcast? I've got a book out. You know, how many people get to talk to Nobel Prize winners at their request? I mean, it's incredible. So I'm very fortunate to be able to do that. And I can talk to him, read his book in a couple of days, a day or two, talk to him for an hour as I just did, and then come away with instant episode that I hope will be valuable to everyone out there, especially younger people in 20s, 30s, 40s, shall we say, in academia and beyond, because that's the target demographic that kind of most represents where I used to be and I'm trying to teach to. So that is my greatest joy. It's kind of the whole thing mixed together, except my greatest pain and work, at least, comes from the long delays between idea and final data product. I mean, our job is to take money and convert it into ink and publications and talks and PowerPoint slides and things like that. And it's a long process. I've been at it this is my 21st year as a professor, and I've been doing cosmology for 10 years before that. So we're looking at 30 years, 3 decades. I don't know how much longer I have it in me. I'm going to try to make it till age 60. We'll see how that goes, and before I think about retiring from the experimental physics game, but we'll see. 10-minute retreat 807 asks, what if the expansionary model of the Big Bang was turned on its head, and instead of each point in space acting as a source of expansion, it was viewed as a sink of contraction? But not a contraction where matter is decoupled from space, but is instead coupled to it, so the scale is constantly changing, blah, blah, blah. This goes on for pages and pages. This person then says, unfortunately, I lack the higher depth math skills to be able to analyze such problems, having only gotten my BS in physics. Well, you're in luck, because you live in a glorious time, because we are able to investigate exactly like that sort of model that you're proposing. And to me, that's the most fascinating thing that we can look at, are alternatives. People think, oh, you want to just prove the Big Bang, right? No, that's not what scientists do. We want to falsify the Big Bang as much as possible so that we can get a closer view, which will be a better view of the Big Bang. So that's what we want to look at. That's what we want to understand. And because of that, we look into things very deeply using the tools and techniques and so forth of modern general relativity, in this case, is what you're asking about. But to answer your question, okay, your hypothesis suggests the model that the scale factor, which is the most important quantity in cosmology, A of t, it's the one that we don't have access to, but we use proxies to validate the underlying truth of the model. We can't measure A of t directly. We can measure the Hubble constant, which is the time derivative of A of t divided by A of t. So it's the scale factor's time change over its scale factor's value. We see that that's increasing. So we know for sure you're wrong now. But in the future, could it be that local clocks and rulers could contract and run backwards? There's nothing that rules that out. In fact, if dark energy suddenly is not a cosmological constant, what could formulate and become different is that we would have a red shift, which would be converted into a blue shift. You'd see objects coming towards you. We don't see any of that. It doesn't mean that in the future we won't see any of that. So this is part of a new type of cosmological model that would be ruined by, again, our current observations. But that doesn't mean it won't be right. But the bad part of this model is that we don't have any evidence to estimate when this will become possible to be tested. In other words, when the average Doppler shift of a galaxy or supernova or baryon acoustic oscillation peak or CMB fluctuation, when those will start to be equivalent to a blue shift, Doppler shifted not red, but to the blue. So this will take billions, perhaps trillions of years before that would happen. But it's not impossible. And you can construct a cosmological model that does just this. In fact, our friend Roger Penrose has a model that has contraction in what's called a conformal cyclic cosmology. It doesn't contract in the normal way that you're thinking at each point in space. It's very much related to this kind of idea of the change in the scale factor over time. You ask a lot of other questions about black holes and stuff I don't really fully understand, but the core idea of your first part is certainly worth pursuing intellectually, if not experimentally. I just don't believe we'll be able to test that, but don't hold your breath. It could be a billion years from now, we suddenly see a preponderance of blue shifts. We don't see any of that now, despite what fraudulent people may tell you about tired light theory and so forth. Okay, the world has gone crazy, says, wow, and not only for members. Yep, that's right. I assume you're not a member and you're here asking me questions. And that was your question. It's like when Homer Simpson asks the genie if he really gets 3 questions, and then the genie says yes, and he says, really? And then the genie says yes, and he goes, are you sure? That's the end of your 3 wishes. Okay, Kenneth Ludwig, who uses his real name. Thank you, Kenneth. What does string theory tell us about what's inside a black hole? Does it depend on how the dimensions are rolled up? Well, that's another phenomenal question. I can't believe how many enormously fascinating and good questions are coming out of this audience. Actually, I can. You guys are so brilliant. I don't have any reason to suspect that you guys wouldn't be able to ask such phenomenal questions. So the true answer is that the string theory provides a picture that's very limited in terms of what we could perceive, but it's radically different from what GR, or general relativity, predicts. So string theory suggests that there may not be a singularity because there may not be infinite curvature and infinite density. The reason for that is that string theory smooths out the little fluctuations that would occur if the minimum length in the universe was below the Planck length and in fact at 0 length. So there's a string length which acts sort of proportional to what's called the string coupling constants. And these set a minimum length scale, and that smooths out curvature, etc. So there are people who have suggested that inside of a black hole there might be something called a fuzzball. But the most important breakthrough in the last kind of 30 years or so has been the ADS-CFT correspondence, that the black hole's interior might be somehow dual, or it might be correlated to the quantum information residing on its surface. So the interior, which is hidden by the event horizon, is somehow shielded from our view in normal cosmology, but it may be that the horizon itself contains information about what's inside its volume. In fact, it does in all black hole entropy models. The entropy is not proportional to the volume, it's proportional to the area of the black. This has many interesting things downstream from it, according to past guest Juan Maldacena. It's supposed to have him back on. I should probably do that one of these days. I want to have Nima Arcani Hameda, and I met him last week in person for the first time in a very long time, and he agreed, gave me his cell phone number, so hopefully that'll get hooked up. I'll ask him this question because it's certainly not a purview of my domain, but I think this is incredible that the difference between string theory and general relativity couldn't be more stark. One is saying there's a singularity of infinite density and temperature, pressure, whatever. String theory says there's a structure, there's some minimum scale, there's some geometry that could in principle be probed, and that the interior of the black hole has information within it that could be projected like a screen onto its surface, the event horizon. So this is an incredibly fascinating topic, and I thank you for that question, Kenneth. Pathfinder Physics asks, what does Eric's theory say about entanglement, geometric unity? To me, it's just geometric torsion, nothing local. The geodesic distance between points on S3, the 3-sphere, is proportional to cosine to the inherent twist in the manifold. I'm going to say I have no idea. I don't know that he talks about entanglement. He does include the role of torsion, which is a much overlooked quantity that is certainly intrinsic to general relativistic situations, but is typically left out on symmetric grounds. But don't forget, there could be other modes of violating locality, reality, and other aspects of quantum mechanics that typically involve entanglement, because Eric features more than one dimension of time, etc., which is probably the most stark and almost outrageous prediction that he's making. So I'm going to punt on this question. B, Lima, Peru. What do you think is the most commonly accepted theory that has the highest chance of being overturned in the near-ish future? Okay, so this is interesting. Wow. I mean, in physics alone, the point is that we really have almost no understanding and of what we could actually expect to maintain its proof or its truth throughout the history of the future of science. There are many different theories, I think. The Big Bang is a theory, in other words, a hypothesis. It's a fancy way of saying hypothesis, or a hypothesis, a fancy way of saying guess. We have many examples in scientific history of a good theory being replaced by a better theory. Newton's laws were phenomenal, but they were overturned instantaneously by Einstein's theory. Again, called a theory, because in math we can prove theorems, but in physics we can't prove theories. We can only establish evidence against theories and therefore break them. So nearest future, what could be done in the next few decades? Could we have a new model of dark matter? That is certainly very interesting. We're already seeing the kind of birth pangs of a revolution and an evolution of our understanding of dark energy, which we thought from the late 90s until the mid-2020s, or mid-2020s, was a cosmological constant, the lambda CDM paradigm. I think that's very much likely to be challenged, maybe overthrown. So I don't know to say that what the timescale, that's very difficult to predict the future, as Yogi Berra would say. But by the same token, I think it's quite fascinating that we live in a time we can test these things, not only see that there is some substance like dark energy, but that's evolving. The fact that we know so little about it and that we often get things wrong is exciting to scientists. It's not a sign of us being fools or being sheeple or whatever. It's an exciting thing. It means there's stuff for you, the younger demographic. I mean, half the audience is younger than me out there. I'm going to be 53 now. I'm going to be 54 on September 9th when my next book comes out, Focus Like a Nobel Prize winner. I hope you all get that. And so it will comment on many of these different topics of what makes a good scientist good and what is a good path to pursue in science. All these questions that you guys are asking, a lot of them will be addressed and answered in that volume of interviews with Nobel Prize winners coming out in just a few weeks. Okay, Dennis FP1 asks, is it possible that a partial answer to the Fermi paradox is that there's too much stuff in the interstellar space, i.e. dust, gas, asteroid fragments, etc. Therefore, starships of any substantial size are highly impractical, if not impossible, because of the unavoidable collisions at relativistic speeds? Oh, that's a great question. So that's kind of explaining the Fermi paradox, which is if the universe is teeming with aliens because we've had billions of years of evolution, there's billions more stars than just our sun and the Milky Way alone, let alone billions and billions of galaxies, maybe 1 trillion galaxies. It may be too messy. It may be too dangerous a drive is what you're suggesting. So they must know about the asteroid belt. Now, it's not really true like the game Asteroids where you basically unavoidably going to crash into something, nor would you really crash into other stars. There is the Oort cloud that has perhaps 1 trillion comets in it, but space is really big. The volume that surrounds the Earth, especially perpendicular to the plane of the solar system that we orbit around the sun in, it's very low density. It's an interesting conjecture. I don't think it's really too terribly much of an impediment. However, there are a lot of grains of sand and so forth, but these aliens, if they're able to travel intergalactic distances, would certainly either have a technology to avoid and see these objects, or even a grain of sand traveling at 10,000 kilometers per second could blow up a current modern Earth-based spaceship. They would presumably have much more advanced spacecraft. But this is perhaps an argument against the current visitation of aliens that are able to move with properties like these tic-tacs and all sorts of cubes and spheres and all sorts of other stuff that I quite frankly have no belief and currently evidence for in my possession, and have not been convinced by any of the guests that I've had on the show who spoke about this that they've actually seen alien craft. Of course, a good scientist will never say it's impossible, but there's so little evidence that they come from because of these practical issues. And then you could say, well, they're not using practical physics, they're using Alcubierre warp drives to warp space-time, and well, then you also have to warp the asteroids and the comets along the path as well. So quite a good question. It may be contributor to the solution to the Fermi paradox. That maybe Fermi himself, there's a book called like 77 Solutions to the Fermi Problem or something like that. Maybe this one will be 78. So thank you for that. Okay, Cameron Bannock asks, with all the new data suggesting dark energy could be variable instead of a constant, I just talked about that. I think I got that right. Yep, you did. How dependent would the constant be on the current models of cosmology? Would we be able to account for it, or would we be back to square one? Oh, God forbid we be back to square one. So, okay, the discovery by DESI, and I have multiple videos by the DESI former spokesperson leader, Kyle Dawson, University of Utah. You can find those on my channel, as well as many predictions about what the cosmological constant is or is not. We now believe, thanks to DESI, that there's a 1 in 30,000, there's less than a 1 in 30,000 chance that the fluctuations that we see in the constancy of dark energy, in other words, the degree of credulity we have in the cosmological constant, being constant, has been shaken, and the evidence for it is likely to be real and not a fluke at this very high confidence level. So it's almost as if we're looking at something, let's say you set your freezer at 0 C to freeze your ice, or -1, and then you see over time it's not really being that constant, and you're sometimes getting ice cubes and sometimes getting puddles of water in their ice cube tray. So maybe varying, maybe shifting, going and fluctuating, but over what time scales and over what distance scales. So this evidence primarily is coming from different ways one slices and dices a set of data from baryon acoustic oscillations, which are the post effects of the cosmic microwave background, similar types of physics that you can see behind me in the acoustic oscillations in this giant CMB globe that I have behind me. Those are kind of the initial conditions at 380,000 years. And then after several billion years, hundreds of millions to billions of years, those patterns get frozen in terms of sound waves as well, and they're called baryon acoustic oscillations. Those act as standard rulers, both the CMB and the baryon acoustic oscillations, but at far different times. One acts in the very high redshift universe, Z of 1,000 in the CMB's case, and in the BAO case, it's acting at Z of 1 or 2. Or 3, something very, very small. It's still billions of years ago, but much closer to the observer than it is for the CMB. So the universe has evolved a lot, and we can still use those patterns of oscillation to reveal themselves as rulers, which help us know by their length how far away they are by measuring their angle. And so it's dependent on a few different things, but the dark matter paradigm and the dark energy paradigm as a cosmological constant, they are in flux. So we know with great certainty that dark energy exists, but what we want to do is understand whether or not there is an evolutionary term, or if it is a constant. Speed of light is a constant, as far as we can tell, going like billions of years. Are these things constant? Is dark energy constant? It seems to be, according to DESI, that dark energy is weakening. Now, we need more data, we need to get more confirmation, but it's one of many very interesting tensions, which means that the underlying model is correct. In other words, people say, oh, you guys don't know what the Hubble constant is. Yeah, but we know we don't agree on the Hubble constant, but we know that everyone agrees that the universe is expanding. Everyone agrees that currently the universe is accelerating. It's just, will it continue accelerating in the future? So the answer to your question, would we be back at square one? No, we wouldn't discard everything. We'd keep some form of dark energy. It wouldn't be a cosmological constant. The universe would still be expanding, still be accelerating for quite some time, but we'd refine our models and not really replace all of physics. But it would be a challenge at one of the biggest, most interesting, newish discoveries of all time, namely the cosmological constant or dark energy. And I mean, changing it to just dark energy, which would be quite insanely interesting in its own right. Okay, Troy H4C. Given atoms are very similar, is it possible there is a coda, a blueprint for their formation, like cells in biology? Yes, I mean, atoms form due to very well understood rules of quantum mechanics, of orbital construction, of the patterns of the valence and conduction band electrons and the electron properties, what gives atoms their chemical nature. There are other properties of atoms, and they are unique, but at their core, they're all built from the same three building blocks, up quarks, down quarks, and electrons. So it's quite fascinating that, yes, they do have a blueprint like DNA in biology, as you say. Okay, DS Crib asked, is geometric unity simply an arbitrary logical structure that maps over the foundations of physics like string theory is attempting, or is there any separate good reason for proposing it, any reason other than just combine the foundational physics theories into one structure? I don't think it's arbitrary. I mean, what Eric's trying to do is a complete overhaul or address all the elephants and mastodons in the room, and wanting to understand whether or not there is a source code for unifying in a geometric fashion, that's the name, that combines fundamental physics, all different aspects of fundamental physics, from quantum mechanics, relativity, into one single standard model of everything, which would then have predictions even for cosmology. And in his theory, he has the cosmological constant not being constant, or dark energy not being a cosmological constant. Now, of course, again, it has been published in peer-reviewed journals, never will be, in its current state at least, although I keep encouraging him to do so. So the way I can think of it is you have this map, and the map has different scales of information overlaid on top of it. What you really want is to know everything. What's the weather going to be like at your destination? How are you going to get into the apartment that you're going to visit after you get on a subway, after you take an Uber, etc. So these are all unified into one thing. It's a super map of physics. It's not arbitrary. It's not based on some flamboyancy or kind of just fashionable choice. I think it is modeled loosely on the standard model of particle physics in a way that supersedes it by adding more dimensions. So he has a 14-dimensional space-time structure with time dimensions, multiple time dimensions, which means there are non-commutative paths that taking one direction in time is not equivalent to going in another direction of time. Time travel is possible. That has implications for locality, reality, as was asked earlier. So it is not arbitrary, like the Dewey Decimal System is arbitrary, but it is a framework which attempts to explain why we see things as we do in fundamental physics. The most interesting questions, as Eric asked Sean Carroll, and he had no explanation for it, was very sloppy. And it's clear, he says it doesn't have the things that it should have. And Eric points out on his X-Feed pinned post that, in fact, it does have the Lagrangian. It does feature quantum mechanics. It does make testable predictions. Again, there will be downstream consequences of the nature of having a fundamental spin 3/2 particle as predicted. That is a prediction. It is falsifiable. We can measure that. Sean didn't address any of that. So it was very disappointing to me that he would sort of just outsource his critical thinking of it. Now, I'm not condoning everything in every way that Eric treated that interview with Piers Morgan. I would have been happier if they came on my podcast. And actually, I've invited them. Sean won't come on, or he was refusing to come on even before this interview, and I assume he'll never come on again. That's unfortunate. I think he should be open to science communication. He knows I've always been a big fan of his work in cosmology, and just because I happen to be friendly with Eric, friendly with Sean, or I was friendly with Sean, he endorsed my first book very nicely. We don't agree about everything. We've had our dispute, but that's what scientists do, Sean. So kind of disappointing again that was our last conversation that we'll ever have on the podcast. I think it's a disservice to the biggest physics audience on YouTube, on elsewhere, that does hardcore science is this podcast. So it's disappointing you won't engage with me anymore, even before this thing with Eric. But the thing with Eric on Piers Morgan was also quite disappointing. There are many levels to your question. I think I may have answered most of them. It's not arbitrary. It's seeking a deeper, better reason for why we see things like 3 generations of fermions. That is a fascinating question. Eric gets frustrated that people don't even care or where that comes from, how that comes about. We just accept it and move on and pass the potato salad. So, and I get it. I get why he's upset about it. But he's a deep thinker, and the attacks and the criticism and the vitriol and the hatred that he gets for his proposals and the accusations of him being foolish or grifter. I mean, who is he grifting? Like big science? I'm doing a video now at the Thunderbolts, and they talk about big space as this conspiracy. It's so laughable. But when people out there criticize Eric for grifting, I mean, can you imagine a less profitable area of endeavor to grift off of? Eric could certainly make a lot more money, attention, fame, etc. from many other branches of the economy, shall we say. So it's kind of betrays the fact that you have other reasons for hating him, including his fame and attention that many of you seek out there. It's sometimes quite pathetic. It's good when people like Sean and like my colleagues here at UCSD and like his colleagues over the different places in the country suggest that Eric has something at least worth listening to. I think it's wonderful that we have these different ideas, and to say that you should stop associating with him and he's evil, and it doesn't affect me at all. Okay, congrats on your 500 episodes. Now sing to the tune of the Proclaimer, says Busy Billy B33. I have done 500 episodes and I would do 500 more. My question to you, what are your thoughts on the JWST so far? This might be a hot take, but I'm a bit underwhelmed at what it has done up to now. True that it has given us many great images and more detail to study so much of the universe, and there have been many puzzling new observations, but not much for explanations. But so far, it hasn't really provided much answers to the big ticket items in cosmology, such as dark matter and dark energy, inflation. Exoplanet science hasn't quite taken off under its watch. Or am I being impatient? Well, sort of yes, sort of no. I predicted on Lex Friedman in 2021, the couple days before it was launched, that it wouldn't have the kind of soul-shaking, earth-shattering impact that the Hubble Space Telescope did, for a very simple reason, which is that it's an infrared telescope. So it does things much differently. And it gets about the same resolution as the Hubble Space Telescope. So it's about 3 times the diameter, which is what sets the resolution, maybe a little bit less than 3 times the diameter, 2.5 times the diameter of the Hubble Space Telescope. But it's operating at wavelengths about 2 and 2.5 times the wavelength, which also reduces the resolution. So the resolution optical telescope goes as the ratio of the wavelength to the aperture size. So bigger aperture and smaller wavelength make higher resolution. Therefore, it has about the same resolution. Maybe it's a factor of 1 to 2 better, and that's great. And it's doing stuff that Hubble could never have done. But it's just the fact that the human being, our visual cortex, is so important to us. If you look at the motor homunculus of how a human being pays attention to its sensory organs, the eyes are like 90% of what we care about. The rest is like our hands, and there's a tiny bit of like our left toe. Well, there's other parts. I mean, don't forget about this book on Viagra. Okay, there are other parts that some of us pay attention to as well. But the brain really focuses primarily on visual stuff. So it's natural that we'd want to be interested to see what a visual wavelength band telescope would produce. And in that regard, Webb is slightly differently of interest. So it's as if saying, like, imagine you had just all the powerful spectroscopy that Webb has capability to do, and that's all we could, quote unquote, see. It would be literally thousands of times better for the science that you're talking about, early galaxies, exoplanets, et cetera, looking at atmospheres on exoplanets. It wouldn't say much about inflation or dark energy because it's not probing that early era of the universe, at least not directly. And that's not what it was designed to do. It was designed to do spectroscopy, imaging, photometry, et cetera, of compact objects, of galactic individual galaxies, not background radiation of gravitational waves, et cetera. This is quite astounding if you only had its spectroscopic abilities. But the press and everything really wants to see these pretty pictures. And in that sense, we've kind of been there, done that as far as the general public knows. And I assume you're a member of the general public, but it's not true that it hasn't revolutionized the understanding of these objects or won't continue to do so. I mean, just in the past few months, we've seen evidence of very interesting science on exoplanets, and then interesting information that may impact the CMB, because there's a claim that these early galaxies produce a certain amount of heat that we stupid cosmologists are mistaking for the CMB. It turns out it's a microscopic, maybe 1% effect at most, which I'm not even convinced about yet, and think needs much more analysis before it goes more viral than it did on social media. This post that the CMB is totally destroyed and massive losses for cosmologists. I'll have a video about that at some point. But no, Webb has been great. It's shown even the existence of this molecule called dimethyl sulfide, DMS. I said in the video I made a couple months ago that life slid into our DMSs, but we don't know for sure. That seems to be a little bit contentious right now. But the fact that we can see the presence of these molecules in atmospheres around other planets and can directly image them and see them without this giant star nearby them interfering and blinding us like trying to see a firefly in front of a searchlight. It's just phenomenal technology. The cosmology results, those are a little bit more contentious. They led to some headlines a couple of years ago with these early spinning galaxies. It's a problem of galaxy evolution. It's not a problem with the model of cosmology. Say you come to Earth now and you say there's ChatGPT and there's AI and superintelligence and all sorts of things going on. There's no way that could have happened in just 4 billion years of life on Earth, 3.5 billion years since the first prokaryotic cells appeared on Earth. That doesn't mean that the age of the Earth is in doubt. It means that your understanding of evolution may need to be modified. And so in that sense, our understanding of galaxy evolution probably certainly has to be modified. A lot of it's based on simulations, which have inputs to them that we need to understand better. And so there's nothing wrong with that. I'm going to take a break in just a minute, go to a July 4th barbecue, come right back and answer the remaining questions. Reminder, you can always ask me questions on YouTube, Dr. Brian Keating. I have a secondary channel where I put explainer talking head videos called Professor Keating Experiments channel. On audio, you can leave comments on Spotify. You can leave a review. I put out polls on Spotify. Everyone likes to get polled, don't you? And we'll come back with more, and also on social media sites such as X, LinkedIn, and Threads, Instagram, Facebook. I maintain a presence there, Dr. Brian Keating, pretty much across all those. All right, so we'll come back. We'll talk some politics. We'll talk about Trump. We'll talk about the USA and Europe. And then a lot of more interesting videos coming up. Okay, more questions coming up, I should say. Stay tuned. Just before we wrap up, I want to make sure that you hit subscribe and join me beyond the Big Bang every week right here. Click to subscribe and make sure to leave a thumbs up. And for bonus extra credit homework, leave a comment. Now back to the ending. Reminder, as always, you should subscribe to the channel or the podcast, where you're listening or watching. Leave a review, leave a rating, do whatever you can. That helps us out. And go to my mailing list, briankeating.com/YT, for your chance to win a piece of the early universe in the form of a meteorite, and learn a lot about meteorites, meteor showers, meteoroids, and other phenomena. I just got back from a lot of meat eating, and my choices certainly were meteor on this 4th of July barbecue season. Okay, VREQ asks, how am I coping with the Trump cuts? Well, the Trump cuts, I assume, in the budget cuts and the big, beautiful bill that was just passed, don't really affect me. I am 100% supported by the Simons Foundation research, the Simons Observatory that I am the PI of. So I am not affected at all. Eventually, the National Science Foundation is going to take over partially in terms of contributions to Simons Observatory, so that would be devastating if those cuts propagate through. We don't have indication of that yet, but we do know the government, even before the Trump cuts, under the Biden administration, cut back all development of new instrumentation at the South Pole. So that really impacted cosmology via the plans for the 4th generation CMB experiments that were intended to go down there, so-called CMB stage 4 in Chile and in the South Pole. But now with the Biden cuts led to a stoppage of those plans as well. It is, I'm not going to sugarcoat it, it's definitely dark times for science funding. My friend Jay Bhattacharya, I've had on the podcast and spent a lot of time with in my life. He's now the director of the NIH. Hopefully he can help alleviate some of the budgetary issues, but some of them I'm not upset with. The cutting of funding to institutions like Harvard couldn't happen to nicer organizations, for those midwit institutions that chose to prioritize support under the guise of free speech to have blockages, encampments, harassment. These are all ridiculous things, errors of the Biden and Obama administrations that thankfully are not really in place anymore. And I don't think that would have happened without a Trump victory. So to complain about cuts of up to $400 million, or Harvard most laughably now appealing to corporations and donors when they have a $54 billion tax-free endowment size of easily enabling them to be on the Fortune 500 list. It's just a joke. These universities are for-profit entities that are restrictionist, isolationist. They don't let in more than the capacity of a good-sized Chipotle can serve on a weekend afternoon. As I said, the bureaucracy, the equity imperatives, and we're being sued at the University of California. I don't speak inside of a glass house alone. We're being sued for the so-called presidential fellowships, which were primarily seen, according to allegations, as a vehicle to achieve racial diversity goals, which is against the California Constitution and the anti-affirmative action policies of the state of California. So those were being accused of ways to get around that. The cuts to funding from the federal government, which eventually flows through to universities, that's a much more complex topic. It's not clear at all why we still adhere to this 1940s and 50s era model where universities were thought to be the only places where scientific research would take place. So money was sent from the federal government, i.e. your tax-paying dollars, to universities for their beneficence and stewardship. And then they ended up using a lot of those funds, and the overhead that I get charged, or used to get charged when I had NASA, NSF, and DOE grants, 60% of that almost would go to support the university indirect cost contributions, which in part, since money is fungible, was used to support vehemently anti-American departments. Thankfully, a lot of that's gone. I did testify in Congress last year about the horrific encampment that was tolerated for 5 days here at UC San Diego. We were harassed here as Jewish individuals, but nowhere near as badly as that MIT, Harvard, physical violence, and so forth. We had a lot of intimidation and student groups that needed to be banned and eventually were banned. UCLA is now protesting against the federal government decision that they violated so-called Title VI, which is equal rights under the workplace rules, not Title IX for equal rights for sexes, which is also problematic. So it's a horrible time in academia right now. I think a lot of it is our own fault. We treated the money like a gravy train. We expected it, and now that it's not coming in, people are crying and blaming it all on Trump, the boogeyman. So we have to see, is this a good model? Do we need to have California state tax dollars to do that, ethnic studies dollars, diversion from physics department grants? Is that where you want your money to go? I think, or could we have a vote from the populace, rather? Have them vote. Where do they want their money to go? It's your tax dollars. I'm not in favor of any monarchy, no kings and all that. But the bottom line is, especially on July 4th, but especially so when it's taking money out of my pocket, I should not have that. As I testified in Congress, you can't learn in a place of fear. You cannot teach in a place of anger and hostility and hatred. And then they use the platform that the university has cultivated and built up through very careful stewardship by colleagues that have long preceded me. And hopefully I contribute to the reputation for scholarship. And that then enables the participation of malefactors to broadcast their malicious, malevolent intentions using a platform that they didn't create. They never cease, though, to fight and cry, literally cry, if they don't get their degrees from this university, which they'll then claim is just a tool of capitalism, imperialism, colonialism, all the other BS isms that they like to bandy about because they lack any notion of what real scholarship is. It's a mixed bag. The Trump cuts will possibly throw a lot of babies out with the bathwater, but a lot of the universities that are suffering the consequences of their illegitimate, anti-intellectual, anti-scholastic, anti-collegial actions and just sucking off the public teat for decades, I have no problem with those cuts. Okay, so those are the ends of the YouTube questions. I had a whole bunch on, you guessed it, X, formerly known as Twitter. Let me go over there. See if I can find any questions that are worth answering. John Anderson says, stick to science, otherwise you'll get in lots of trouble. Well, I wish you told me that before I answered the previous question about the Trump budget cuts and my true feelings about the nature of decrepitism in academia. Next one comes from Cannot Be Blank. What's your favorite thing about Chile outside the observatory? Chile is a really cool country. The people are wonderful. Food is pretty terrible, but the people are wonderful. The culture there, the centering of the culture around the night sky and the stars, the galaxies, the things you can see down there you can't see anywhere else. I guess that's kind of related to the observatory, but not really. They have a thriving non-microwave background astronomy component to their wonderful country, but a big part of their economy, and they're smart about it. They don't push it away like other locations are trying to NIMBYize huge telescopes, which could only benefit them intellectually, culturally, etc., with minimal impact on their terrain. You're talking an observatory that takes up less than an acre of land in a country that's 5,000 kilometers long in Chile, or states that are hundreds of millions of square miles perhaps across. It's a wonderful country to visit. It's because it's such a large and diverse, geographically diverse from north to south, with this huge desert in between, with sea level to 22,000 foot tall mountains within a 30-mile distance of the ocean. You get incredible diversity of the flora and the fauna and the landscapes, salt flats and nature preserves and hot springs in the desert. And then down south, it gets freezing cold in the winter. and as the launching point off for trips to Antarctica, even. The north, of course, Chile has access to Easter Island, which for some odd reason is owned by them. So it's an incredible place, incredible country, very much considered, in my opinion, the second world. It has some first world attributes like the capital city, Santiago, where 90% of the population lives, and the Atacama Desert areas where these telescopes and massive mining operations take place. But then even there, you'll see people bathing themselves in the streets next to where they are washing off their llamas and their sheep. So it's quite a mixture, a culture clash. I guess we have that in every country, but it's pretty stark. You see that very eerily so. But then you'll see all the people together, and they work quite well together. It's very cosmopolitan city, Santiago. I wouldn't say it has the soul of what I'm told Buenos Aires or Sao Paulo or Rio has. It's very comfortable. It's very clean, modern, very European, as I said. And then you have access to this unparalleled astronomical resource called the Atacama Desert in the mountains of the Andes. Incredible. Okay, he also asks another question. If you were sent back to the year 1 AD for a week and your sole purpose was to advance civilization as fast as possible, what would you teach them, ideas or concepts or technology? What would you leave them with? Well, this is kind of similar to the question I used to ask all my guests. What piece of information would you put on your monolith from 2001: A Space Odyssey? And I got some beautiful, not 3D printed, but acrylic hand-casted monoliths in my other studio. These monoliths are kind of like time capsules or messages or talisman for future generations. And I always used to ask my guests, Nobel laureates included, what would you put on your monolith if you knew it would last a billion years? And I think the sentence, and this kind of echoes Feynman's cataclysm question, which is what sentence expresses the most amount of information in the fewest words. And Feynman said it's the atomic hypothesis, that atoms are made of whirling bits of electric charge that spin around ceaselessly, boundlessly, and in combination can make up all the matter that's important and matters to us. For me, I'd say the cosmic microwave background explained that it has these acoustic oscillations in it, which later lead to baryon acoustic oscillations. And that would incorporate not only Feynman's atomic hypothesis, because the pattern of light that we see directly traces the pattern of ordinary matter, dark matter, and the ordinary matter is made up of hydrogen atoms primarily, and a bit of dark matter, a lot of dark matter. So I'd be able to encapsulate the core principles of all of cosmology in a very, very small amount of information, which would subsume everything that we know about physics is contained within cosmology, except for maybe biophysics doesn't contain itself within cosmology. Although if you talk about aliens and you expose things to the harsh light of the origin of life problem, then indeed it does include and incorporate the aspects of so-called biophysics. So I actually love cosmology because it's the broadest, widest ranging of all. Last but not least, deep safe, prevent, protect, and preserve. The Jasterism. Why Eric Weinstein? Just because he's your buddy, he clearly is toxic deviant who will brainwash enough numpties because of his holy crap of rubbish called geometric unity will never be accepted. Well, that's not really a question. It's kind of a comment. I guess you said, why Eric Weinstein? I think he's very interesting. I think he has fascinating ideas. I think he shines a harsh light on the reality of physics and theoretical physics. I fight with him a lot about his opinions bleeding through in kind of expansionary critical creep into experimental physics, which is certainly not stagnating over the past 50 years. And the problem is when he communicates those ideas and people that are influenced by him pick that up. But there's a lot of other influencers, ranging from Sabina Hassenfelder, John Horgan, I think is another guy I've heard about, that are also kind of fighting the same fight or claiming the same claims, end of physics. I actually disagree with all of them, and I'm more in the David Deutsch school. And reminder to stay tuned for my interview with him, 2 hour long. I think I went deeper with him than any guest I've had on, and he's went deeper with me than any podcast he's ever been on, because we really resonated in terms of our understanding of what is important to search for, how do you convey these things, what is knowable, the boundary of philosophy and physics, and the impact of it. So Eric has a lot of those positive attributes, unlike, I venture to guess, you. So there are many detractors, haters, people that don't like him. I think he's a big boy. He can handle those criticisms. He's a complicated person, doesn't believe in things like peer review necessarily that I do support. And I always say to him my favorite phrase, that peer review is the worst form of scientific iteration, except for all the rest. He hates when I say that. He thinks it's a trope, but I think it's true, echoing Winston Churchill. There have been reviews. As long as there's science, we need scientific, impartial, bipartisan review. We're not politicians. There's no opinions in science. There's just facts and data. And it may turn out he's completely wrong. I am interested in seeing that. The amount of effort that's dedicated to him on the channel. Again, I didn't have him on for 2 years. This is the first interview in 2 years. And all of a sudden, there's all these trolls coming out making summary videos of him and me, 3 or 4 different channels of people that have these incredibly grandiose names for them, their channels. The bad boy of science, Sam. Come on, you got like 20,000 subscribers, so you're not that bad of a boy. But I get it. You want to get clicks. You want to glom onto Eric's name. You want to use me. I'm kind of flattered in that. But the bottom line is, didn't have him on for 2 years. Came out when we had a lot of information from Desi about the cosmological constant, which is a prediction, and you can disagree with that, but it was in his paper from 4 years ago, and you can say all you want about him being non-serious because he called it literally a work of entertainment, but the reason he did that, as he says, is because claims that his copyrights have been violated by people at the highest levels of physics, like Ed Witten and Natty Seiberg and others. So that's his perspective. If you're not going to agree with it, go right ahead. Be my guest. You don't have to agree with him whatsoever. Okay, the last critical, I'm ending off with 2 critical comments, and then I'll end with a big bang. Okay, this is back on YouTube. Frenchie, Frankie, and Henry, you speak to a lot of interesting people, but the constant edits make your videos almost unwatchable. I'm the type of person that will usually watch a conversation from start to finish, but I've never been able to do that with one of your videos. If you just record and play the conversation, your podcast would be 10 times better. All right, well, I'm always looking for constructive criticism. You have to edit conversations. If you didn't edit them, there's so many breaks and pauses, and the flow would be disrupted, and there's no logical progression. I've put a lot of effort into entertaining and educating, starting at a lay level to get an entry point for people that want to learn about the topic, that are interested in the topic, and then slowly ramping up with different ways to retain interest and retain attention. And I've monitored that, and YouTube does a wonderful job of telling me exactly how good I am at retaining your braining. And I have to say, for a non-professional, remember, this is my side hustle, people. You don't pay anything to watch this. Listen to this, you get it all for free. Welcome those that support me through the YouTube membership. It's a tiny amount. I mean, I'm blessed by the 150 of you there, and Twitter supporters, and hundreds and hundreds of people on Patreon and other places, but doesn't cover the bills. So I'm putting in a lot of stuff. Appreciate that's not what you like, but guess what? 94% of the audience disagrees with you, Frenchies, Frankies, and Henrys. So I think there's editing in the beginning. A lot of people complain also that I have these captions in the beginning in giant font, and they don't even watch the interview to see that that's only for the first 39 seconds, which is the biggest component of the algorithm weighting by YouTube. So if you knew a little bit about how YouTube works, you'd know that you only have 30 seconds, sometimes 2 seconds, 3 seconds before someone clicks away. And then they'll miss perhaps the remaining 3,598 seconds of just solid gold interviews with laureates from all different walks of life. So I appreciate the feedback. I'm not going to change anything about it. I don't edit them myself. I have a team that costs money, and they're very good. They're very good professionals at Legacy Media. I've got a media consultants and so forth that work with me. Josh Reef and others do great work. Patty Galloway's helped me out a lot. And the YouTube channel's metrics just keep growing up and to the right. They're just blowing up and to the right. So I can't wait to see what happens in the next 500 episodes. God give me the strength to continue for 500 more. Maybe that's 5 years. Maybe that slow it down a little bit, take it out to 10 years, and we'll see where it goes. I'm having a blast with it. I'm enjoying all the videos I get to do, all the interviews. We've got so many coming up. We may be switching to a 2-a-week schedule of release because I don't want to have backlogs. When I have brilliant guests that are having breaking news like we had with Vera Rubin or Desi, these are embargoed data sets in some cases. I don't want to sit on those for the 8 weeks I have backlog, which is a great problem to have as a podcaster. But I'm not Joe Rogan. I'm not doing 3 a week or pushing them out to the intertubes. So I hope you appreciate what you're getting. I hope you'll continue to support me. I do read the comments, although you're not supposed to, but I obviously love reading all these. And even the little snipes at Eric or at my production style and so forth, those don't really bring me down. So keep it up. I'm really looking forward to the rest of the year, and you should be too. The next half of the year is going to be straight hot white fire. You're going to hear guests you've never heard on podcasts before, And some guests you'll hire return back. And it's quite gratifying to get letters of requesting me. I get letters requesting every day to have a guest on, but to have them come from Nobel laureates and Pulitzer Prize winners and professors and colleagues and friends and people I've never heard of, but just know that you're going to be blown away by their intellect and their output. It just brings me a lot of joy. I'm glad that there's an audience out there. I do it without you, but I really would like to spread it to more people. Again, you get it for free. It's the education I wish I would have had when I was a wee lad and trying to learn about science and how to go to a library, if you can believe that. No audiobooks, no podcasts, but I'm doing it. And I'm hoping that you'll enjoy it too. So, Brian Keating, expressing gratitude. Don't forget briankeating.com/YT. Get a meteorite possibly. Join the mailing list. Enjoy the rest of the half of 2025 because you're going to have to buckle your seatbelts for what's coming next.